this video, we will discuss about take gifts from the richest pile. You are given an integer array gifts denoting the number of gifts in various piles. Every second you do the following. Choose the pile with the maximum number of gifts. If there is more than one pile with the maximum number of gifts, choose any. Leave behind the floor of square root of the number of gifts in the pile. Take the rest of the gifts. Return the number of gifts remaining after k seconds. So what they are saying is that in the input, we are given an integer array gifts and we are given another integer k, right? So we have to kind of perform k operations on this array gifts, right? And in each operation, we need to find out that which is the maximum element in the array, right? Then whatever is that maximum element, we need to replace it with the floor of square root of that particular element, right? So in this case, the maximum element is 100, so it will be replaced with the floor and square root of it, and that we will insert back to here, right? Then in the next operation, again we need to find out that which is the maximum number in this array and then perform the same operation. These operations have to be performed k times, and at the end, whatever are our array elements, we need to find their sum, and this sum is going to be our answer, right? So if we see in this particular test case, so we are given four operations, right? So first of all, we will find out the maximum element. So the maximum element is 100. So the floor of square root of 100 will be 10, right? So our array will become 25, 64, 9, 4 and 10, right? The operations left are 3. Then again, we will find the maximum element. So it will be 64, right? So square root of 64 will be 8 and floor of it will also be 8. So 25, 8, 9, 4, 10. Number of operations left are 2. Then which is the maximum element? 25, square root of 25 is 5. So it will be replaced with 5, 8, 9, 4, 10. Right? The number of operations left are 1. Now the maximum element is 10. So the square root of 10 will be 3 point something, right? So since we are taking floor, it will become 3. So the array will be 5, 8, 9, 4, 3. And we are done with all of the operations. Now whatever is our array state, we need to find out the sum of all its elements, right? So what will be the sum here? 5 plus 8, that will be 13. 13 plus 9, that will be 22. 22 plus 4 will be 26 and 26 plus 3 will be 29, right? So the answer of this particular test case will be 29, right? So now how to solve this? So in the brute force approach, we can follow a straightforward approach that whatever we are expected to do in each of the operation, we are exactly going to do the same. Meaning, first we need to apply k operations, right? So you can say that while k minus minus, I'm going to do something, and that something will happen for each of the operation k times, right? Then in each operation, what we need to do, we need to find out the maximum element from our array, right? So we will find its index int maxi index, right? Because we need to replace it. So that's why we are finding out the index, and then you will run a for loop of array from 0 till n, and you will check that if gifts of maxi in, whatever is the maximum element that you have taken, if it is less than gifts of I, in that case you will update your maxi index to I, right? So once this loop finishes, we will be able to get the maximum element from the array, right? Now we need to replace that maximum element with its square floor and square root. So in the gifts at the index maxi int, what we will do? We will take the floor of square root of gifts of maxi int, right? This is what we will do in each of the operations. Now when we are done with our operations, what we will do? We need to find out the sum of our array, right? So we will take a long. We need to return a long for the sum. So we'll take it as 0, and then we can just iterate that for auto I in gifts, inside sum we will add I, right? And at the end you can return this sum. So this is what our brute force will look like, that we are applying k operations. In each of the operation, we are finding out the index of the maximum element in the array. Then we are replacing that maximum element with the floor and square root of the maximum element. Here, this floor can be dropped. Like if you only do the square root, then also it will work. Why? Because gifts is an integer array, right? So when square root will give you a decimal value, the decimal part will already be removed when you will be inserting into gifts, right? And floor also will give you the same result. So you can skip this floor here if you want. Then after applying these k operations, we are running a loop to find out the sum of our array elements, and then we are returning that sum, right? Now in this particular case, what is going to be the time complexity? So see, first this loop is running k times, and inside this, for each k, this loop is running n times, right? So this particular part is running n into k times, right? And this loop is running n times. So can we say the time complexity of this particular code will be order of k into n plus n, somewhere around this, right? So this is going to be the time complexity. And what will be the space complexity? It is constant, right? Because we have not taken any extra space, right? So now how to optimize this? Is there any chances of optimizing this further? So see, the main part over here that we have to do again and again is to find out the index of the maximum element, or basically finding out the maximum element, right? This operation we need to perform every time. So we need to see if somehow we can optimize this operation from n to somewhere around constant or log n, right? If we are able to do so, then we will be able to optimize this particular approach, right? So see, what do we want? We want the maximum element in each operation, right? Can I use such a data structure which gives me the maximum element always out of some number of elements in less time as compared to order of n? So can I use a max heap over here? Can I use a max heap? Because max heap always stores the maximum element at the top, right? And the heap operations take the time of log n, right? So finding out this maximum element will be reduced from order of n to log n if I use a max heap, right? So simply what we can do is that we can create a max heap, right? And we can store all the array elements initially in the max heap. Since it is a max heap, it will always store the largest number at the top. So your array elements would be stored in this particular format: 4, 9, 25, 64, 100. Right? In this format, the array elements will be stored. Then in each operation, you can take the top element, right? Pop it from the heap and insert back the square root with the floor of that particular number. Basically, you will first take out 100 out of this, then you will find out this value for 100. So it will come out to be 10. So you will insert back 10 into the heap. But now since 10 is not greater than 64, it will not be inserted here. 10 will come here, right? This is what your heap will look like. So in the next operation, when you will see, the maximum element will be 64. So again, you can take the top element and perform the same operation, right? And once we are done with all the operations, simply to find out the sum, we can take all the elements out from the heap one by one and find the sum of the elements, right? So let's look at the code. So first of all, since we want to create a max heap, we will create a priority queue, because in C++, max heap is implemented using a priority queue, right? Let's name it PQ. Now, in this, we want to store all the elements present in the vector gifts, right? So we can do it right now itself. We will write gifts dot begin, comma, gifts dot end, right? So this will store all the elements present in the vector gifts inside our priority queue, right? Next, we need to perform our k operations. So while k minus minus, what are we going to do? We need to take the top element, which will give us the maximum element of the array, right? So it will be pq dot top. And we need to pop it now because we are going to replace it. We are going to replace it with what value? The value will be floor of square root of maxi, right? This is what we are going to push inside our priority queue. Now, once we are done with our k operations, we will take a variable sum, which will be 0 initially, right? And now, while our PQ is not empty, right, we will take the top element and we will add it in the sum. right? After adding it, we will pop it from the priority queue, right? And at the end, we can return our sum. So this is what our approach will look like. So let's run this code. So in this particular case, if you see that first we are running a loop k times, right? And inside this, we are accessing the top element of the priority queue and performing push and pop operations. So these operations take log n time. So this loop is taking k into log n time, right? And here we had inserted all of our elements into the priority queue. And so this is going to take order of n time, right? So the overall time complexity of this particular code will be order of n plus k into log n, right? And now space complexity will not be constant because we have taken a priority queue. Inside this, we are storing all the elements of the gifts vector. So if the size of this vector is n, so the space complexity for this approach is order of n, right? So our test cases are accepted. Let's submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.